Hello everyone. I'm going to make a demonstration on model building in ErdasImagine. So in this demonstration, what I'm going to do is I'll show you how to build models to calculate indices. I will start with what the definition of these indices. So the normalized difference vegetation index is calculated by taking the difference of the near infrared and the red band and divide that by the sum of the near infrared and the red one. Yeah. And scale the NDVI. Sometimes it's very important to take into account the high and low NDVI values of the image. And that would be the NDVI of individual pixels minus the NDVI, the lowest NDVI of the image of your area of interest, divided by the range of NDVI over the area of interest. That's the maximum NDVI over the image minus the minimum NDVI over the image. Once you have the scaled NDVI, you can easily calculate the fractional impervious cover by taking the square of the scaled NDVI, and the fractional impervious surface simply is 1 minus the fractional vegetation cover. Okay. I think that there is a mistake here, which I thought I have fixed it in class. This is supposed to be a vegetation cover. Okay. All right. This doesn't come up. All right. So, yes, there it is. So the vegetation cover is the square of the NDVI, and the impervious surface is 1 minus the fractional vegetation cover. Let's go to ErdasImagine and see how these indices can be calculated by using model building. So the first thing is you have to bring in the stacked image of the layers that you would need to calculate. So I'm going to import the Akaki river basin with stacked layers or stacked bands. So this is the image I have. It's imported here. Fit to layer, fit to frame. So this is the stacked image with band 2, 3, 4, 5, 6, and 7. So I have these 6 bands stacked together in one image. Once I have this, there is a simple way of calculating NDVI where you simply go to unsupervised classification. Because of the repeated use of NDVI for various applications, ErdasImagine 2014 has NDVI calculations already built in. If you click here, it will take you directly to the dialog box where you can calculate the NDVI. So this is the input file. You define an output file. Let's say, let's give it a name. Akaki NDVI. Let's say built-in. Okay, built-in. Okay, so that's the file we wanted to. And the formula for NDVI we already talked about is the near infrared minus the red divided by the sum of the near infrared and the red band intensity. So here you also see the check marks where how those how the NDVI is calculated. So once you go through all these, okay, next thing you can do is, now you see the band 3 is the red band and band 4 is that's, well, it calls it a band, but it's layer number 3. Okay, so let's say okay. So that's the NDVI, normalized difference vegetation index. Okay, normalized difference vegetation index. So there are other indices here. You can see a lot of indices, mineral composite, normalized burn ratio, normalized difference, built-up index. All these indices are already built in, so you can use those to calculate, what you, depending on what you actually need. So right now what I wanted is the NDVI here. So this is a quick way of calculating NDVI without getting into so much of trouble. Okay, and then we wait and see how. All right, done. Let's see. Let's import the NDVI file. It should be there. Okay, that's the built-in NDVI we have, and here we go. So now we have the built-in NDVI for the entire Akaki river basin. Oh, okay, normalized difference built-up index. Okay, so the built-up index considers layer number 4 and 5. 4 is the near infrared and 5 is the mid infrared. So let's see. So this is okay. Akaki and the built-up area. Okay. Close, and let's import. So this tells you the built-up area. Now you know how to calculate those built-up areas as well. You can zoom in. Okay, you can zoom in, zoom out, and do all kind of things that you might be interested in. All right. Now let's see how we can calculate the NDVI using Model Builder. For that, you go to the toolbox. Okay, we'll be interested in the Akaki stacked image. So you go to the toolbox. There is a model maker here. So in the model maker, you will have this palette where you have the different tools. This is for inputs and outputs. Okay, input and output. So our input for the NDVI is stacked layer image, and you can define functions using the circle here. So this circle takes functions. Okay, functions. You can move functions left and right, up and down, and the outputs can be again represented like this. Let's have another output here. So in NDVI, your input is going to be, you double click on the icon on the box, and you can add the input. That's that stacked layer. Okay, it's assigned 8-bit integer. Now you declare this as floating because we are going to do divisions, and when you divide integers, you may not get integers. So it's good to define as a floating. Okay, for the sake of calculation, it would be defined as floating. Okay. Now this is a connection. You can connect this, and you can also connect. Okay, I have to click this here. Okay, connect, and the output of the function or the operation will be stored here. There are two ways to store your output. One is in temporary format. If you don't need the intermediate product, you can simply say that's a temporary product. Let's see what it means. So you can say it's a temporary raster only. In that case, you don't need that raster at all. So at the beginning, let's have that raster and give it a name. Okay, so let's say that is Akaki and near infrared minus the red. Okay. Minus red. So that's the difference. Okay. Okay. So data type, it should be a floating type. Okay. Floating type. And if it exists, we say delete, because every time we calculate, it should not ask us what to do with it. So if you check this, every time you do the calculation again, it replaces the existing file. So let's say okay, and do the same thing here. And this is going to be, instead of minus, that's the NIR plus the red. Okay, so again, this is going to be floating. Okay, and delete if it exists. Okay, so the operation here is for Agagi, that's the red band, which is the third one, the third band, plus the first one is minus, right? The near infrared minus the red, and this is going to be the near infrared, the near infrared plus the red. Okay, so that does the calculation here and stores them in these output files. So we can simply run this and see what happens. Okay, so this is the run button. You run it. All right, that's done. So we have the difference. We can add those two rasters here. Okay. Okay, that's the difference. Okay, so this is the difference. Let's fit to the frame. So this is the difference between the near infrared and the red band. We can also have the sum of the two bands, that is the plus. Okay. Alright, so this is the first one. This is the sum of the near infrared and the red band, and this is the difference between the near infrared and the red band. This the ratio of these two is going to give us the NDVI. So we go to the model builder again and do the division. Okay. And we need to have an output file here. So it's going to be, what we're going to do is divide these two and get the NDVI. Okay, so let's do the division. That's going to be the difference divided by this is the sum. Okay, and this, let's give it a name as NDVI. Like NDVI, this is a model. Okay, the model, and I want to have it as image. Okay, and it's going to be a float, and delete if it exists. Okay, and because this might give me trouble, I want to remove these files from here, so that when it does the calculation and replacement, it wouldn't ask me, or do you want to replace the existing blah blah. Okay, all right, so run. Okay, done. Let's see. Let's import the NDVI, which we have just calculated. Okay. Okay. So here, let's see if we have it right. You go to the metadata, and you can calculate the histogram and see. Now, what you see, you don't see the histogram here, so it's just a black and white. The reason that happened is we do have, when we do the divisions, okay, here there are zero denominators somewhere, so it's very important to filter out those divisions by zero. to do that, you set in conditions. Okay, so instead of just doing the division here, you can set in conditions. So in the function drop down here, you can go down and look for conditional, where you set in that zero value if the denominator is 0, or the ratio if the denominator is different from 0. So what you do is, you remove this, okay, delete this. So I'm going to have a 0 either. So you set the first argument, which is, set 0 if the denominator, which is the sum, is 0. Okay, so if the denominator is 0, so this is test. When you have a test, you use a double assignment, okay, double equal sign here, or you do the division. If it's not 0, if the denominator is different from 0, you do the division of this. Okay, first you have to open a parenthesis here, so you have the numerator divided by the denominator, and that's if otherwise. Okay, so otherwise you do the division. Okay, now we have defined a condition, and let's run this whole thing. First, let's remove this, remove layer, and now we run the model with a new condition. There is a problem. Let's figure out what went wrong. So in the conditional statement, we said either 0 if the test, we don't need this part, so the test is already put there, so you delete that. So this is the test. If the sum of band, the near infrared and the red band is 0, then we set 0, or we take the ratio of the difference and the sum. Okay, ratio of the difference and the sum. So we close the parenthesis here. That's the second condition. Okay, once we have that, let's run the model. Good, done. So close that, and let's see the new NDVI that we have just calculated. So that's the NDVI model image. Okay, not the model. Yeah, we built the model, and that's from the model. Okay, so this is the NDVI from the model, and that's this one is from the built-in function. So that's how you can use a model builder to calculate indices, fractional indices. We can also calculate the scaled NDVI. Okay, for the scaled NDVI, we need to add a new function here and an output. What happens to the scaled NDVI is we scale it based on the maximum and the minimum that we have, where the scaled NDVI searches for the individual NDVI values. Okay, so I'm going to put a bracket here. So the individual NDVI values minus the global minimum. Okay, the global minimum. Here in the global function, you look for the global minimum. So here is the global minimum. That's for the NDVI. Okay, you delete this part, it will give you the error that we had before. Okay, close the parentheses and do the division here. That would be the global maximum minus the global minimum. Okay, let's see, where do we have the global maximum? Yeah, the global minimum and the global maximum. the global maximum of the NDVI. Okay, let's open a new bracket here, minus the global minimum. And close the bracket. Okay, so that's going to be Akagi NDVI scaled NDVI S based on the model. Okay, and it's going to be floating single. And if it exists, it's delete the existing file. Okay, so now you run it. Akagi error cannot be deleted. Okay, because it's already displayed. Okay, cancel. Okay, to all dismiss, and we remove it from here because it's already displayed. It cannot rewrite that file. Okay, so let's say delete, remove layer, and then we go back to our model and run it. Okay, close, and let's see the scaled NDVI now. Open raster, send as the scaled NDVI. Okay, that's the scaled NDVI. So once you have the scaled NDVI, you can go to the model again and add a new operation here. Put this one a little bit down here, and let's have a new operation and a new output here. So you connect these two. What we are going to do is calculate the fractional vegetation cover. In that case, that's going to be the square of the NDVI. Okay, that's the square of the NDVI. So simply multiply those values. Okay, so that's the arithmetic function. All right, so this is going to be NDVI times okay, so that is going to be Akagi fractional vegetation cover, and it's going to be a float. Okay, and delete if it exists. Okay, so I'm going to remove the scaled NDVI because it's going to give me an error. Now run this. We have the fractional vegetation cover. The impervious surface would be 1 minus that value. Okay, so let's display that and see. So the most recent should be the vegetation cover. That's right. Okay, so this is the fractional vegetation cover for the Akagi River Basin. So the next thing we would want to do is take this, okay, expand this a little bit further, okay, and add a new operation here and an output. So the new one would be take the fractional vegetation cover, okay, the fractional vegetation cover 1 minus fractional vegetation cover, and that's going to be the fractional impervious surface. Okay, fractional impervious surface for Akagi. Okay, so delete if it exists. Okay, now let's go, and if here we need to remove this layer to avoid the error message. Okay, run. So you can also include annotations that can tell you what kind of operations you have done in model builder. To do that, you use the annotation, the letter annotation, and that will help you to figure out what you have done at the beginning. So that's a kind of putting a note to your model. Alright, let's go back and see the fractional impervious surface that we have just calculated. Okay, so this is the fractional impervious surface, the Akaki River basin. So you can clearly see the water bodies here as white. Okay, and forest areas as very dark, and the Addis Ababa region was a light, very light gray. So now you know how to build a model to calculate all these things. So you can do all these calculations separately, or you can have a single flow like this. Okay. So to build or to have a notation here, for example, this is the input. So you can say that is input struct image. Okay, and the last one is fractional impervious surface. So you can put a note like this and save your model for future use. Okay, the only thing you need to change is this part. So if you want to prompt yourself all the time, whenever you want to add a different image, you just click this, check this box, the dialog box, this dialog. So every time you run the model, it prompts you to bring in an image. Okay, so that's how you calculate fractional indices using ErdasImagine 2014. I hope you will find this demonstration very valuable. Thank you very much for watching my videos. Bye bye.